question is valid anagram. So what is anagram? Anagram is if we have two strings, let's say string 1 is RAT and string 2 is CAT. If we try to compare both the characters of the strings, if they are same throughout, then these strings are anagram. So the question asks us that it will be given two strings, that is string S and string T. What we have to return is if they are anagram or no. For a string to be anagram, we will compare all the characters in string S as well as in string T. If all those are equal, that is the same, then we would return true, else we would return false. Let's take another example. If my S is ANAGRAM anagram, and if my input string T is NAGARAM, so we have to return are they anagram or not. So if we compare character by character, see here A is 2 times, and in this string T we have A as 2 times. Now N is 1 time here and N is 1 time here as well. Now G is 1 time in string S, and string T we have G also once, R is also once, R is also once, and A is also once, A is also once, M. So therefore both the strings string S and string T are anagram, so we return a true. Now as you have understood the question, so what would be the solution for this question? Let's think first of a brute force solution. The extreme brute force solution that we can think of is, we would first sort the string S that is given to us, and then we would sort the string T as well. After sorting, what they will become. For the example, let's take an example for this solution. Let's say my S is RAT and my T is CAT. So first I will sort this string S. So if I sort it, it becomes ART and this becomes ACT. Now if we now compare character by character, if this is not the same character, then we would return a false. So for this example it is false. So the time complexity for this solution is big O of n log n to sort the array, plus we have to compare character by character, each character by character. So at worst case it would also take us big O of n. So the time complexity is big O of n log n plus big O of n. So let's think of an optimal solution for this question. The optimal solution would be, let's take a hash map of size that is 26, okay, from A to Z. Now what we would do in string S, we would increment the count of the character. So this is the my hash map of int comma int. Okay, this is my hash map. So what I would do, my first string is this one and this is my second string. So RAT in my hash map, I would take R, the first character, and then I would increment its count from 0 to 1 and I would push in my hash map. Now I go to the second character A. Now A is also 1, I would put it in my hash map. The next is T, so I will add T, same thing. Now I have added my entire string S. Now it's time to check with the string T. The string T is CAT. Now what I will do, the first character C, I would decrement its value in the hash map. So what I will do, C, and I would take out from the hash map C's value, but in the hash map we don't have C, so the C's value would be count would be 0 now, and I would decrement it by 1 and add it here. As I have added this, we will go further to A. Now A's count is 1. A's count is 1, so I would decrement it by 1. Now it becomes as 0, that I would further add into my hash map. The same thing for T. I would take T, I would see does T have any value greater than 0. So T has its count as 1, so I would decrement by 1 and make it T comma 0. So this is also T comma 0. Now here we have done both the strings S and T. The next step is to iterate the hash map and check if to to check the hash map and check if all the counts are 0 or no. If they are not 0, then we would return a false. If they are all zeros, if they all are 0, we would return a true. Okay, this way we will solve the question. Why? Because the intuition is, if my first character, the first string is, let's say, CAT, and my second string is, let's say, TAC. Now if I increment all the characters count, they would be something. Now if these are the same characters, then if I decrement them, they will all become to 0. If they have different characters, then that would not become 0. In this way we would solve the question. So let's see the pseudocode. The first thing we would be doing is, if my string S and T both's length are not same, they could never be anagram, so I would return directly false here. Now I would create a hash map array of 26 size, all initialized to 0. Now for each character in C, that is character C in my first string S, I would increment it counter by 1. Okay, in the same way for the entire string we would do that. Now in string T, the second string, for every character we would subtract its frequency, and for all the characters we would do the same in T as well. Now if both the strings were anagram, all its frequencies, that is count, would have become to 0. So now we would loop iterate in the hash map, and we would check if their frequencies are 0 or no. So if any of the value is not 0, then we would directly return false, or else after iterating through the entire hash map, if there is no one 0, then we would return here as true. As the pseudocode is very simple to understand, I think you have understood the question. So, and the solution as well. Here is the C++ implementation of the same thing what I had given. The same thing, it's written in C++. Now this is in Java, the same thing, the entire code is written here, and this is the Python code. Okay, thank you. If you have found this video helpful, please like and subscribe, and if you have any doubts, please comment in the section below. Thank you.